Great, it's recording now. Let's talk about section 3.6, the chain rule, the chain rule. For me to introduce this topic, let me show you this basic idea here through this example. Consider that Paul earns $20 per hour working somewhere. So we have a rate here, $20 per hour. And Paul works 40 hours per week, 40 hours per week, 40 hours per week, second rate. He doesn't work overtime, okay? Question, how much does Paul earn per week? So, not hard to see that if we multiply these two rates, right? $20 per week, and then times here, let me just close it and open it again. The other rate, which is 40 hours per week, we should be able to figure out the answer to this question, right? We should be able to figure out the answer to this question. Let's see. Let me just change the color. That's good. All right, so first rate says that Paul earns $20 per hour. Second rate says that Paul works 40 hours per week. Not hard to see that if we multiply these two rates of change, right, that are related somehow by this number of hours worked, eliminating hours, we come up with a new rate. 20 times 40 is just $800 per week, right, per week. So this shows that somehow if we multiply two rates of change that are related by some quantity, in this case time, it is possible to come out with a new rate of change, right? With a new rate of change. This is the idea that kind of inspired mathematicians to think of this chain rule, which comes in two forms. It is used to compute the derivative of composite functions, and it comes in two equivalent forms. The first form is inspired by what I just showed, right? That multiplying two rates, it is possible to get a new rate. Remember that the derivative is the instantaneous rate of change, right? So multiplying two instantaneous rate of change that are related by some variable, in this case, the variable u, it is possible to come up with a new rate of change, instantaneous rate of change. Form one is this: derivative of y with respect to x equal derivative of y with respect to u times derivative of u with respect to x. And this form is due to Leibniz, German mathematician, right? And we're going to start with this form. Later, we will get more sophisticated and we'll use the chain rule, form 2, which says that the derivative of the composite function f of g of x is equal to the derivative of f evaluated at g times the derivative of g. I will explain this second form to you later in details. Okay, so let's start with the first form. The two forms are equivalent, and we're going to use both throughout this course. So try to understand both forms. First, using dy dx equal dy du times du dx. This is the first form of the chain rule. Let's talk about it. All right, example 1 says, find the derivative of this function, this composite function, y equal 3x minus 4 raised to the 5th power. How can we get this derivative using this first form of the chain rule? Well, first step, you have to identify what's going to be the variable u. Let u be equal to, and that is going to be always equal to wherever you see inside this expression, this composite function. So it's going to be always equal to the inside, 3x minus 4, 3x minus 4. If you are calling this u, then it means that your y can be written as this raised to the 5th power, but this is u. So your y can be written as u raised to the 5th power, right? Looks simpler, the function now. Now you go ahead and say, okay, derivative of y with respect to x, according to the first form of the chain rule, should be derivative of y with respect to u times derivative of u with respect to x. Now, this guy, the derivative of y with respect to u, when you look at this, y equal u raised to the 5th power, should be 5 comes down, u stays with one less here, 4, right? This is the derivative of y with respect to the variable u. Times derivative of the function u, look at this, with respect to x. That should be the derivative of this part, which is just 3, right? Once you take the constant outside, derivative of this 0. So this is just 3, right? 3. Multiplying 3 and 5, we get 15 u raised to the 4th power. But now you want the answer in terms of x, right? The question was given to you in terms of x, not in terms of u. So finally, you are going to write, instead of u, its equivalent form written as 3x minus 4, right? 3x minus 4. And then it's raised to 4th power, right? And then done. This is the derivative of y with respect to x using the chain rule in its first form. Yeah, everybody okay? Questions are welcome. Let me know if you have questions. All right. And this first form, again, due to Leibniz, he emphasizes the fact that we are multiplying two rates, in this case, two instantaneous rates of change, right, to get a new instantaneous rate of change, right? And this idea will be used far in the future when we look at, for instance, related rates. Right? We will use this idea. All right, guys, another example. Example 2. Find the derivative of y equals sine of 4x squared plus 3, a composite function again, Solution using the first form of the chain rule. Here I have the y is equal to sine of 4x squared plus 3, right? I write out the chain rule in its first form, dy dx equal to dy du, or equivalent to derivative of y with respect to u, times derivative of u with respect to x, right? But now, what is u? Well, u, remember, just right on the side here, u will be always equal to whatever you see inside this function, always u. That's how you get your u. And if that is u, then y becomes sine of u, right? U, so we can simply look sine of u. Now, what's going to be dy du? Anybody could tell us in the chat what is dy du, the derivative of y with respect to u? Anybody? Or you can say it loud. So, activity on the chat. Cosine of u, right? Very good, Marcos, very good. And thank you, because this is something that you should recall on your homework, right? The derivative is cosine, but cosine of u, because we are taking the derivative with respect to u, right? With respect to u. So cosine of u. Now, let's put parentheses here. Cosine of u, right? Times this derivative. What should be the derivative of u with respect to x? Hint, look at this relationship between u and x. Well, what's the derivative of u with respect to x. Anybody could write it on the chat? Very good, very good. 3 students, right? 8x, right? Very good, Marcos, Miguel, excellent. Gonka also 8x, right? 8x, so very good. 8x here, 8x. This is it. Now, this should be the answer, right? Let's follow, remember that general rule, the simple stuff at front, the more complicated stuff following, right? This should be the answer, but the only issue is we don't want the answer in terms of u, we want the answer in terms of x, right? They ask us the question in terms of x. So simply replace u by its value in terms of x, which is this 4x squared plus 3. 4x squared plus 3. Okay. And that's it. This is the answer, right? This is the final answer. Very good, guys. Okay, so this was example 2. Before I go over example 3, probably you should do some work. Let's see. Yeah, let's do some work. Let's do at least one, and then we'll go back to example 3, right? Can you try this following the example that I just gave you? This one, number 1. Could you figure out that the derivative of y equal twice x plus 10 raised to the third power, using the chain rule in its first form? Hint, chain rule. Chain rule form 1. Leibniz form is this: dy dx, the derivative of y with respect to x, is equal to dy du, the derivative of y with respect to u, times du dx. And hint for you guys, let u be equal to the inside, always this u, the inside function, let's call it. So can you do that? And then the last hint will be this. Then y is supposed to be this raised to the third power. Well, we are calling this u. So y should be u raised to the third power, right? To the third power. So after you do that, you should be able to find your derivative. Derivative of y with respect to x, derivative of y with respect to u, times derivative of u with respect to x, right? Chain rule in its first form. So get this, and multiply them, right? Multiply them and then simplify, show your answer in terms of x. Let's see some activity on the chat room, which is good. Very good, Gonka. Yeah, excellent. Good. Excellent, very good, you got it. Yeah, very good, guys, very good. So let's do it together, right? What should be the derivative of y with respect to u, looking at this relationship between y and u? Well, 3 comes down, u stays with an exponent 1 less, 3 minus 1, 2, right? This is the derivative of y with respect to u. Now, looking at the relationship between u and x, which is this, what should be the derivative of u with respect to x? Well, the derivative of this part is just 2, right? 2, constant out 2, right? The derivative of this 1, and the derivative of this 0, right? 0. So this will be just 2, right? 2, this part. Then multiply. 2 times 3 is 6, u squared. That should be the answer, but mathematicians don't want to see U. U was just a tool for us to get the final answer, right? Mathematicians they want to see the answer expressed in terms of X. Not a problem because I can rewrite U as 2X within parentheses, right? Plus 10. And then that should be raised to the second power. And this is it, right? This is the answer. Now, to identify your answer, guys, advice, look for this. Look for the final answer. Where is the final answer, Professor? Well, it's here, right? 6 times 2x plus 10 raised to the second power. This is this, right? And then check. U is supposed to be this, right? U is 2x plus 10. Well, that's what we said, right? U, 2x plus 10, good. And then we said also that y is supposed to be equal to u cubed, y u cubed, right? So start here and then you then check the rest, right? There you go. Mm-hmm. All right, here is another one. Let's see. Yeah, this, and then we'll give more examples. Try to do this now, guys. Number 2. Find the derivative of this. Derivative y with respect to x using the first form of the chain rule, right? Chain rule. And as a hint, I can tell you that you should let u be equal to the inside, right? The inside, 5x squared. I am going to write this number, this variable x as x raised to minus 1. So this will look like a polynomial, right? Yes. Let u be this. Then your y has to be equal to, I'm calling this u, right? So u raised to the a power. With these two, then you go ahead and apply the chain rule in its first form. dy dx equal dy du times du dx. Equivalent to derivative of y with respect to x, derivative of y with respect to u times derivative of u with respect to x. Get it from there, right? And then simplify and your answer should come out. Mm-hmm. Mm-hmm. Yeah, when you get your final answer, remember, if exponent is negative, just put it down, right? Because we know that mathematicians don't like to see negative exponents as part of the final answer, so you just put it down. Mm-hmm. Uh-huh. Very good, guys. I'm glad that the students are participating. Conca, yeah, you made my day. Very good, excellent. Very good, you got it. Yeah, let's start with the derivative of y with respect to u by looking at this relationship, right? It's clearly a coming down, u raised to 1 less 7, right? That's this derivative. Now, derivative of u with respect to x. This is u. If you take the derivative of u with respect to x, 2 comes down, multiply 5, that's a 10. 1 less stays, 10x, right? Derivative of this part, minus 1 comes down and multiplies 6, right? And here, 1 less stay, minus 1, minus 2, minus the derivative here of the identity function x, which is 1. So this is it. Now, this should be the answer, right? But I have the following issue. I have this x with negative exponent. So write it as 1 over x squared, right? minus 1. That's better. So this will be 8u to the 7, 10x plus 6 times 1, 6 over x squared minus 1, right? Almost done. Now, this u, rewrite it in terms of x. Look, u is this, right? This 5x squared minus 6 over x. Notice I'm writing this down here. So to avoid the negative 1 as exponent, right? And this raised to the 7th power times 10x plus 6 over x squared minus 1. Excellent, right? Minus 1 there. And this is a perfect match with this guy, right? Remember, look at the final derivative. The final derivative, which is this. This is this guy, right? From there, check, right? U is this, right? Is there with x in the bottom. And y equal u raised to 8. So this is it, right? The last one. Very good, guys. Now we have new forms, cosine raised to the 4th power, cotangent of 3x minus 8. Let me show you more examples so you can go back to this. All right, let's go back to the lecture. And let's see more examples. There are more examples there. Example 3 now. Suppose they ask you to take the derivative of y equals sine cube of x. Sine cube of x. Well, solution, remember, whenever they give you something like this, it is preferable to rewrite it as this: sine of x raised to the 3rd power. This is what this 3 in the middle up here means, right? The sine function has been raised to the 3rd power. Now, why I wrote it like this? Well, because written this way, it is easier to identify what u should be. U, remember, always the inside part, right? This inside part. So this is u. Sine of x. Okay, so then y will be sine of x cubed, but we are calling sine of x u, so it will be u cubed, right? U cubed. That's it. Now write out your chain rule in its first form: derivative of y with respect to x equal derivative of y with respect to u times derivative of u with respect to x, right? This is a chain rule in its first form. So this guy is equal to what? Well, looking at the relationship between y and u, that will be 3 coming down up front. U stays with 1 less 2, 3u squared, right? And this part should be the derivative of u with respect to x. Looking at the relationship between u and x, derivative of sine of x is just cosine of x, right? Good. Almost done, right? Except for the fact that this u shouldn't be part of the final answer, right? U was just a tool. So instead of u, right, it's equivalent in terms of x. U is sine of x, right? It's squared times cosine of x. And now place this exponent right here in the middle. So it will be finally 3 times sine square of x multiplied by cosine of x, right? This is how you should see this among the choices. Okay. Very good, guys. So that's that. Let me show you another example. One more example here. Example 4. Go ahead.
So
yes.
We are not changing the sine of x to cosine of x. We are just putting the square, right?
Yeah, the square simply went from being outside with this parentheses. Mathematicians place it in the middle here up here. This is the same as this, right? Okay. It's just a different way to write it. Yeah, to avoid unnecessary parentheses, they use this notation. Yeah, this is just the same. Okay. Yeah, great. Very good, guys, very good. So now let's see this other example 4, which is find the derivative of this composite function y equal secant of tangent of x. So again, start by identifying your u. Who can tell me what should be u here? What is u by looking at this function? Anybody? Or you can write it in the chat. What should be u? And the hint. 3, 3, 4. Tangent of x. Right? Very good, guys. I think you got it. Tangent of x. Always choose u to be the inside. We're gonna call later this the inside function, right? That's always u, the inside function. So this will be tangent of x. Great. Now, if we call tangent of x u, then y should be equal to secant of u, right? Of u. Now we are supposed to write the chain rule here in its first form. Derivative of y with respect to x equal to derivative of y with respect to u times derivative of u with respect to x. This derivative, by looking at this relationship between u and y, is just the derivative of secant. But the derivative of secant, remember, is secant of u times tangent of u, right? Tangent of u. Secant of u times tangent of u. And I have placed these derivatives, in case you don't remember the derivative of secant, in sheets. They are available on our website. I think this one is here. This is the one for inverse functions. This one. Here it is, right? Derivative of secant multiplied by tangent. So have this, you can have these sheets printed out or handy, right? When you take your exams, if you forget, they are there. Derivative of secant times tangent. Times derivative of u with respect to x. Derivative of u with respect to x, this part, should be equal to, looking at this relationship, the derivative of tangent, right? The derivative of tangent is secant square of x, right? Again, it's here in case you want to check. Derivative of tangent, secant square. Very good. Now, finally, just rewrite u in terms of x is tangent of x, right? To complete the presentation of this answer. Tangent of u again, tangent of x, right? And this one, secant square of x. That's it. And this should be your final answer. Okay. Okay, guys. So very good. We have included now.
So
go ahead.
Yeah, I just had a question. Does that turn into anything else? Like taking the trigonometric function of a trigonometric function?
Not really, Marcus, because here secant of tangent, then tangent of tangent, right? Secant is 1 over cosine, tangent is sine over cosine, so nothing can be simplified. And then this is secant square of x. Look, the input values here is x, the input value here tangent. If you can simplify, you should, but this one cannot be simplified.
As far as
right?
Okay.
Yeah,
all right,
as
cool.
far as it goes. Excellent.
Right, thank you.
Very good question. Great. Happy to help. So now let's do it here, right? Ourselves with this first version of the chain. Yeah, and then we will go over the other one. Can you try to get the derivative of this guy? Y equal cosine raised to the 4 of x. Hint, rewrite this as cosine of x raised to the first power and let your u be the inside function cosine of x. So therefore your y should be u raised to the 4 power, right? With these two, figure this out, find the derivative of y with respect to x as derivative of y with respect to u times derivative of u with respect to x. Go ahead and finish this, please. Number 3. So we can move on. Yeah, try, guys. Very good. Gonka, very good. Number 3. I think
I'm not sure.
yeah.
That u part. I know it's 4 cosine of
Yeah, but what
to
about the
third
sine?
power.
Yeah, it's okay, but the sine. Remember the derivative of cosine minus sine, right? Minus sine. Remember? Yeah.
Yes, I do.
Yeah.
Yeah.
Yeah, derivative of cosine minus sine. Use this. Yeah. Yeah, but it's very close to the answer. Very close. So try just to attach the sine. Yeah, it's good. Mhm. All right, let's do it together, okay? Derivative of y with respect to u, derivative of y with respect to looking at this relationship is just minus sine of x, right? Minus sine of x. No, sorry. This is this one, right? So be careful there. Let's be careful there. Derivative of y with respect to u, I have to look at this relationship. It's just 4u to the third power, right? 4u to the third power. I see someone posting an answer. Yeah, Ma, I think you got it. Excellent, Ma. Yeah, very good. You got it. Yeah, it's a little bit tricky. Yeah, so this is the derivative of y with respect to u here. Now, derivative of u with respect to x is here where we have to take the derivative of cosine. The derivative of cosine, remember, is minus sine, right? Minus sine of x. All right, so this should be the answer, right? I'm going to put the minus up from minus 4u to the third power sine of x, right? This should be the answer. But, you know, mathematicians don't want to see u, right? They want to see the variable x instead. So just substitute u for cosine of x. But this cosine of x, when cubed, mathematicians write it like this, cosine of x cubed, and then sine of x following, right? That's it. So now, again, in order to facilitate identifying your answer, I explained, look for the final result here among all these choices. This is here, right? And then just confirm the rest, right? Look, u was cosine. It's true, right? And then y equal u to the 4, also true. So then, therefore, is this, right? Yeah, very good. Excellent, guys. Try to do this and then we will move on to the second form of the chain rule, okay? Yeah, let's try to do this, guys. Y equal cotangent of 3x minus 8. And as a hint, again, let u be the inside function, right? 3x minus 8. And if that is u, then y can be written as cotangent of u. And then we're gonna use this, right? dy dx equal dy du times du dx. And if you need to remember what is the derivative of cotangent, here it is. Here it is. Minus cosecant squared, right? Yeah, use that. Yeah, and remember, in the end, you must express your answer completely in terms of x, right? U is just a tool, an aid to get this done, right? Yeah. Yeah, it's called the chain rule in its first form, its basic form, right? Marcus, very good. Number 4. Yeah, it's perfect, Marcos, but I think you missed the du dx, so try to fix it. Yeah, Gonka, very good. Yeah, very good. Number 4. Gonka, very good. Ma, excellent. Marcos, now I see everything. Yeah, good. Ma also. Very good, guys, very good. So we start by this, right? By writing out this dy du, the derivative of y with respect to u, looking at this relationship. Basically, it's the derivative of cotangent, but the derivative of cotangent is minus cosecant squared, right? Cosecant squared. It's here, right? I show you derivative of cotangent minus cosecant squared. Great. Now times derivative of u with respect to x. Derivative of u with respect to x, looking at this relationship, is just 3, right? The derivative is 0. So times 3. Now 3 times -1, -3, cosecant squared of u. But you have to write this in terms of x. Cosecant squared of u is equal to 3x minus 8. So 3x minus 8 here. And this should be your final answer, right? I see. Yeah, very good, Marcos. Yeah, you notice, right? The 3 needs to be up front. Yeah, and then with this, you just identify your answer with this final answer. Where is this here? Well, you can see that that is for number 4 here, right? Minus 3 cosecant squared of 3x minus 8. Then just confirm, right? This guy, u equal 3x minus 8, u equal 3x minus 8. And y equal cotangent of u, y equal cotangent, right? Everything perfect. Good. That's it. Very good, guys. Very good. Okay, so this was the chain rule in its first form. Now, this form works very well when you have a composition of only 2 functions, because it's easy to see that multiplying the rates, you get a new rate, right? However, guys, sometimes you may have to deal with the composition of not 2 functions, but 3 functions. So mathematicians realize that this approach, even though it's good and serves to see what is really happening with the rates of change, is not appropriate when you deal with more than 2 functions, right? So that is why Newton came out with the second approach for the chain rule, and it uses this idea of inside function and outside function. I will explain to you now. So going back to our notes, we're going to talk about the second approach of the chain rule, which says that the derivative of the composite function f composed with g is equal to the derivative of this function outside, which we are going to call the outside function, evaluated at the inside function g of x, multiplied by the derivative of the inside function here. Okay, this is called chain rule in form 2, and is due to Newton. Uses Newton notation. All right, now, Professor, too mathematical here. Is there another equivalent way to look at it? Well, if you want an alternative to look at this chain rule in its second form, try this, right? Equivalent language right here. Equivalently, the derivative with respect to x of a composite function, right? Composite function will be equal to the derivative of the outside function, the one that goes outside. So equal derivative of outside function. Okay. Evaluated at the inside function. You keep this inside function as it is. You leave this alone. Right? So evaluated at the inside function. Okay, so the derivative of the outside function evaluated at the inside function. For you to see it clearly, outside function f. And remember that u, that's the inside function. This inside function. Inside function. It will be always clear what's the inside function, what's the outside function. I will show you how to identify it. But then it's not over, because this will be multiplied, should be multiplied by the derivative of the inside function. Derivative of inside function. Okay, so this is another way to look at this second form of the chain rule, which is heavily used, very practical, derivative of inside function. So basically it's the derivative of the outside function between quotations, because you have to keep this inside fixed, and then times the derivative of this guy, right? I will show you with examples how that works. All right, so suppose they ask you to figure out the derivative of this composite function, y equal x cubed minus 4x plus 2, all raised to the 5th power. Solution. So quickly, you identify what is the outside function, and then what is the inside function. Well, I'm going to use colors. I'm going to identify my outside function in blue here as the 5th power of some input value, right? 5th power function outside. And my inside function will be what we used to call u, remember? The stuff inside, x cubed minus 4x plus 2 inside function. Now I'm going to follow this chain rule, right? This chain rule, which says that the derivative of a composite function should be equal to, right here, y prime equal to what? Start with the outside function. Derivative of the outside function will be 5 coming down, something here raised to 1 less, 4, right? But what is this for something? It's this inside function. So you keep this inside, you leave this alone, right? So leave it there, x cubed minus 4x plus 2 times the derivative of this inside function, right? I'm going to write it here, derivative with respect to x of x cubed minus 4x plus 2. Okay, so the derivative y prime of this composite function will be 5x cubed minus 4x plus 2 raised to the 4th power times this derivative. But anyone could tell us what is this derivative? Derivative of x cubed minus 4x plus 2. You can write it on the chat. You can say it. I see. Students are writing stuff there. Excellent, excellent, Ma. Yep, very good, Gonka, too. Right? Yeah, so 3 comes down, right? 3 comes down. And then, more students are saying, very good, Miguel. Yeah, 3 comes down. X raised to 1 less, 2, right? 3 down, 1 less here, minus. Derivative of this 4x is 4. Derivative of 2 is 0, so nothing. So this should just stay like this, right? And then we're done. This is the final answer, right? 5 times x cubed minus 4x plus 2 raised to the 4th power times 3x squared minus 4. That's it. Very good. As you can see, you don't use the u, you don't use the multiplication rates. It's just outside function derivative, keeping the inside function alone. I was inside. So they multiply by the derivative of the inside function. Here is another one. What if they ask you to figure out the derivative of this composite function multiplied by 5? Y equal 5 times 2x to the 7 minus 3x squared, all raised to the 9th power. Okay, again, so focus on identifying quickly what is going to be your inside function, your outside function, right? In blue, I am going to identify my outside function. Look, this raised to the 9th power. Professor, you are not taking 5? Well, 5, I know is a constant, right? And we know that constants, we can take them outside of the derivative. So don't worry about this 5. So this is outside function, the 9th power, right? And this is going to be my inside function. Look, 2x to the 7 minus 3x squared. So now the derivative of this composite function will be 5 comes out, right? It's a constant, right? And I just focus on taking the derivative of this composite function. Start with the derivative of the outside function. That's going to be 9 coming down as it is, right? 9. And then something inside will be raised to 1 less. 9 minus 1, 8. And then you have to multiply this by the derivative of the inside function. The inside function stays right here. 2x to the 7 minus 3x squared. And then you have to multiply this by the derivative of the inside function, right? 2x to the 7 minus 3x squared. Okay. Now, anyone could tell us this is going to be just 45, right? When you multiply 2x to the 7 minus 3x squared raised to 8. Anyone could tell us what is this derivative, the derivative of this polynomial function? On the chat or verbally, you know, what is that derivative? I see written on the chat. Yeah, Gonka, excellent. Marcus, Ma. Yeah, I'm glad, guys, that you are all tuned, right? Yeah, very good, very good. So it will be the 7 comes down, multiplies 2, that is 14 here, right? 14. X stays with 1 less here, 6. Minus 2 comes down, multiplies 3, 6. X stays with 1 less than 2 is 1. I don't have to write 1 as exponent, right? So this should be it. And this should be the final answer, right? The final answer. Notice it's left in factor form. Don't expand anything. Just leave it in factor form or exponential form also called, right? Leave it alone. That's your final answer. Okay, it's the form 2 of the chain rule. Here is one more, but perhaps first we should practice, right? And then we will go back to this. Yeah, 2 more there. Yeah, we will come back to this, but let's practice first. Can you try on your own now this this one first? Yeah, this I have this. I have another one. Product rule. Yeah, let's practice on with this one perhaps. Yeah, very good. This one. Can you try this, guys? Number 6, do this. I'm gonna give you a hint as usual. This is a composite function, the sum of 5 pi t over 2 minus cosine of 5 pi over 2 times t. In order to find the derivative of s with respect to t, you have to find the derivative of this composite function first and add it to or subtract it with this derivative, right? Derivative of cosine. For this, apply the form 2 of the chain rule, right? We're going to identify clearly what's the inside function, what's the outside function. Look, this is your outside function. This is going to be your inside function. This is a constant, 5 pi over 2. Remember, constants, they just came out. Then here, outside function cosine, inside function, this 5 pi over 2 inside function times t, right? Can you try this, guys? Yeah, get this derivative, subtract them, and that's it. And look at your answer among the choices. Remember, the derivative of the outside function, keeping the inside function alone there by itself, leaving it alone. And then times the derivative of the inside function, right? That's how the second form of the chain rule works. I see. activity on the chat room, which is good. Let's check these answers. The first one. Very good, Deep. Gonka also. Excellent. Good work. Good work, guys. Very good. Excellent. Look, the derivative of this part should be derivative of the outside function sine is just cosine, right? Cosine of something. But what is that something? The inside function, right? It stays here. 5 pi t over 2. Leave this alone. Times the derivative of this. But the derivative of this, notice that since this is just a constant, it's just the constant part, right? 5 pi over 2. Minus derivative of cosine. Derivative of cosine is minus sine, right? Minus sine, but minus sine of what? The inside function, 5 pi over 2 times t, multiplied by the derivative of the inside function, which is just this constant part, 5 pi over 2, right? Then just simplify. Notice that this will be writing the constant part up front. Remember the simple stuff first, followed by the complicated stuff, right? This is this, minus or minus plus 5 pi over 2 up front, the constant, then the trigonometric function following, right? Yeah, 5 pi over 2t. And this is a perfect match with this guy, right? Very good, guys. Excellent. Example 3, find the derivative of y equals 6 times tangent of 3x squared minus 7x. So again, quickly, you have to identify what is the outside function. In this case, this will be your outside function, right? Tangent function. And what is the inside function? Well, in that case, will be 3x squared minus 7x, right? Professor, why you don't consider 6? 6 is just a constant that we're gonna pull outside of the differentiation, right? So don't worry about that. All right, so once you have identified the inside function, the outside function, go ahead and use the rule, right? The chain rule in second form, which says the derivative of a composite function starts with the derivative of the outside function. The 6 is a constant, so it comes outside. But what it should be the derivative of tangent? Well, the derivative of tangent, we know is secant squared, right? Secant squared, something. But that something is this inside function. You leave this alone. 3x squared minus 7x. That's the derivative of the outside function evaluated at the inside function. And then you multiply by the derivative with respect to x of your inside function, 3x squared minus 7x. All right, so this will be equal to what? Y prime will be 6 times secant squared of 3x squared minus 7x times this. What is this derivative? Anybody could type it on the chat or say it? Derivative of that polynomial function 3x squared minus 7x. Very good, very good. Yeah, very good, guys. Derivative of polynomials, you should know them really, really well. Excellent, Gonka, excellent. Very good, right? Derivative of this part is 2 comes down, multiplies 3 is just 6x minus derivative of 7x, 7 constant comes out, derivative of identity function x1, 6x minus 7, right? And this, believe it or not, guys, is the final answer. Leave it in factor form, that's it. All right, now let's go ahead and show what to do if you encounter this radical as part of your composite function. Find the derivative of this guy, y equals square root of 12x minus x to the 7. All right, so quickly, again, you go ahead and identify clearly what is your outside function. This will be your outside function, right? The radical function, the square root function, to be precise. And the inside function should be the function that is inside, right? The square root function, this, right? So according to the chain rule in its second form, the derivative of this composite function should be derivative of the outside function, derivative of this square root function, right? But recall, we have a result, right? We worked on this before. The derivative of the function square root of x with respect to x in simplified form is just this, 1 over twice a square root of x, right? Use this, write this down somewhere, have it handy when you take your exam, you may need it, right? Derivative of square root of x, 1 over 2 times the square root of x. We're gonna use that. So the derivative of the outside function will be 1 over, just like in here, twice a square root of something, but that something is this inside function, right? Leave the inside function alone. Okay, done with the derivative of the outside function, right? Now, times the derivative with respect to x of this inside function, 12x minus x to the 7, right? So this derivative y prime should be equal to 1 over twice a square root of 12x minus x to the 7 times, what should be this derivative? Anybody on the chat or verbally, you can tell me? The derivative of this 12x minus x cubed, x to the 7, sorry. Yeah, very good, Marcos. 12 minus 7x to the 6, right? Excellent, excellent. Yeah, this derivative of polynomial functions, you should really know very well. All right, this is it, right? Derivative of this 12, derivative of this 7 coming down, one less stays negative 7x to the 6. That's it. And then to present your answer, just simplify this guy multiplied by 1 is just the same, 12 minus 7x to the 6, all that over this, right? 2 multiplied by the square root of 12x minus x to the 7. That should be it. Very good. Now, following this, try to do on your own, and also following this formula, right? Try to do this. I saw a radical function here somewhere. Yeah, but I think it requires, I see it, I found it. Yeah, this is it. Can you try this? Q equal a square root of 17 r minus r raised to the 5th power. Find the derivative of the function q with respect to r, okay? So hint, outside function is in blue, the square root function, and inside function is this 17r minus r raised to the 5th power, right? So there you have the two functions. So follow your chain rule and figure out q prime, the derivative. And then also I want to write here, recall the derivative with respect to x of the square root function, this function, is in simplified form 1 over twice a square root of x. Right, this should facilitate the computation of this derivative. I see when a student has posted an answer. Let's see, let's check. Question number 7. Deep, very good. You got it. Yeah, very good, Ma. Very good. Excellent, excellent math also. Very good. Yeah, it's not that difficult, right? If you have this handy, helps you a lot. Start with the derivative of the outside function, the derivative of the square root function. That is 1 over is twice a square root of what? This inside function, right? Leave the inside function alone there. Okay, and then times the derivative of this inside function, derivative with respect to r of this 17r minus r to the 5th power. But what is this derivative? Anybody could tell us or write it on the chat? 1 over twice square root of 17r minus r to the 5th power times the derivative of 17r minus r to the 5th power is a polynomial function, right? Should be derivative of this part 17, right? Minus 5 comes down, r raised to the 4th power, right? Very good, very good. Yeah, very good. Manling, yeah, she got it, right? Yeah. Remember, this 5 comes as it is first up front, and then what is one less is the exponent. So then just write this nicely, right? 1 times any quantity is just the same quantity. So this on the top and this on the bottom, right? Twice the square root of 17r minus r raised to the 5th power. That's it, right? That's it. And that is shown on choice A. Very good. Excellent. Very good, guys. Very good. So now there are some other forms that require some tricks. But first, let me ensure these 2 forms. Let me see. Let's go over first this form. There are 2 problems here. I'm going to do the first one. I'm going to let you do the second one. It's a combination of the product rule and the chain rule. You will see. Look, here for number 9, they are asking you to figure out the derivative of this multiplication of 2 functions, and one of them is a composite function. So how to do this using the chain rule form 2, right? Let's do it together. So here I start by writing out my function y equal 3t multiplied by 5t plus 2 raised to the 4th power, right? Let's make it smaller. So this, I will call this my function f. This, I will call it my function g. To apply the product rule first, f times g derivative is equal to f prime g plus g prime times f, right? It's a product rule, right? So applying the product rule, it will be the derivative of the first part, first factor, f, which is just 3, right? 3 times the second function as it is, 5t plus 2 raised to the 4th power, plus the derivative of this. For the derivative of the g function now, I notice is a composite function. Here is the outside function. Here is the inside function, right? So we're going to apply our chain rule there. Start with the derivative of the outside function. That's going to be 4 times something raised to 1 less here to the 3rd power, but that something is the inside function, right? Remember, we leave the inside function alone, times the derivative of this inside function. The derivative of this part is 5, the derivative of this is 0, so just 5, right? Now, that is just the derivative of the composite function, but remember, we have to multiply this by the other function as it is, the 3t, right? 3t. Okay, good. But now notice that all the choices are in factor form. So expanding this wouldn't be a good idea, right? Instead, we have to factor this carefully. How can we factor this? Advice, guys, is a tricky question. So look at the parts that are repeated, right? Parts that are repeated, Professor. Yeah, for example, this number 3 appears also here in this second component, right? This we should factor out. Now, notice also that this guy, 5t plus 2 raised to the 4th power, appears here 5 to t raised to the 3rd power, right? This is another repetition. So then the greatest common factor sort of should be 3 times 5t plus 2. You take always the one with the smallest exponent, smallest 3, right? Compared to 4. So 3 raised to 3rd. This is going to go outside. Then open, close parentheses, something will go inside. What is inside? Well, 3 into 3 is 1. This guy into this guy is just 5t plus 2, right? Plus 2, plus. Look, this 3 into this 3 cancels this 3. 4 times 5 times t stays, right? And this gets canceled with this, right? So this is it. Now just simplify that. Yeah, it's a little bit tricky. Question here. Factor out. Very good, Marcos. Very good. Factorization here, right? But it's a tricky factorization. You will see in the end. Not necessarily the regular factorization. Okay, now this will become 3 times 5t plus 2 cubed, right? And then 5t. This is 20t, right? 20t. Look, 5t plus 20t, 25t, right? 25t plus plus. I have here the number 2, right? So plus 2. And this is it. This is what you have to look for among the choices. And if you do that, you will see that that is located here. See, right? You follow that, guys? 3 times 5t plus 2 cubed is here. 25t plus 2. There you go, right? Yeah. Can you try the next, number 10, on your own? I will leave this for you as a reference, right? It's a tricky question again. It's a special type of factorization, right? Yeah, but it's for you to see that sometimes the answer will be written in certain particular forms, right? Yeah. So try to number 10. In the same way, use the product rule, right? Yeah, probably the hint should be make this your f function. Yeah, let's write it bigger here. Y equal 4t times 2t plus 3 raised to the 5th power. And what we are saying is that you should identify this with your f, this with your e for the product rule, right? And recall this product rule. F times g prime equal f prime g plus g prime f. Yeah, that's the product rule first. And when you're doing the product rule, you will encounter this composite function, use the chain rule with outside function and inside function, right? Let's write here as the outside function this. And the inside function this. Yeah. I see. Someone posted an answer. Gonka, you made my day. Excellent. Good work. Yeah, you got it. You got it. Yeah, you got it. Yeah, a lot of algebra factorization. You know, we're putting stuff that we learned before together, right? Yeah, but with practice, it should be easier. So let's do it together, right? So applying the product rule, y prime, let's write it in green. Y prime, applying the product rule, right, should be equal to what? Well, it should be equal to derivative of f, which is just the number 4, times g as it is, 2t plus 3 raised to the 5th power, right? According to the product rule. Plus derivative of g, derivative of this composite function. So let's apply our chain rule, right? Start with the derivative of the outside function, which is this, right? 5 times something raised to 1 less here. 4, the inside function stays as it is here, right? Leave it alone. Times derivative of this inside function. Derivative of the inside function should be derivative of 2t is 2, derivative of 3, 0, right? So it's 2. Times the other function f as it is, this guy, right? 4t. Now let's apply this tricky factorization, right? Identify the factors that are the same, 4 and 4 the same. This guy is the same as this guy, but with different exponents, right? So we're gonna factor out 4 together with this guy, 2t plus 3 raised to the smallest exponent. Smallest exponent compared to this 5, right? So this is going to be to the 4 power. This. I open, close parenthesis, right? Yeah, now this guy into this guy, what's that? Look, 4 into 4, 1. This guy raised to a 4 power into this guy raised to a 5th power. 4 factors cancel, 1 stays, right? So 2t plus 3 stays. Raised to the 1st power, I don't have to write the 1 there. Plus. Now this guy into this guy, look, 4 into 4 will cancel this 4. This guy will cancel this. What is left? 5. There's a 2, and there is a t, right? T, that's that. Now just simplify, right? Simplify. So it will be 4 times 2t plus 3 raised to the 4 power. Look, I have here 5 times 2 is 10t, right? 10t. This 10t plus this 2t, 12t, right? 12t. This together with this. 12t, and then there's a 3 by itself here plus 3. And this is what you have to look for. And this appears here, right? You follow, guys? Yeah. Sometimes students ask me, Professor, is there a way to pull out the 3 here? Yeah, there is a way even to factorize, but notice, is this a special factorization, the one that they are showing, right? So that's why I said it's a very tricky problem. So in some cases, will coincide with the, yeah, yeah, I'll explain slowly then. I see this, they are asking for a very deep. All right, so deep. Basically, when you pull this out, right, you understand why we're pulling this out, right? 4 from here, maybe we highlight here. This 4 came from the repetition of 4 here and here. This guy, the green guy, this one, came from choosing between these two, the one having the smallest exponent, because the one having the smallest exponent is present here and here somehow, right? You follow this deep now? This part. Now, how we fill this up? I'm going to write it here on the side, okay? How we fill this up? Well, you take this term. Yeah, we're going to write it on the side. We take this term. Yeah, so we're going to take this guy, right? 4 times 2t plus 3 to the 5th power. And we're going to divide this guy into this guy. So this way. 4 2t plus 3 raised to the 4th power. Look, notice these two guys, they cancel, right? 4 and 4. But this into this is just one of these, right? 2t plus 3, because the other 4, they cancel, right? Subtracting the exponents, 5 minus 4, 1 here, 1 here, right? You don't have to write that. Yeah, this is this guy, the one that we wrote here, right? Maybe we should use a color. This came from here. Right? Now, how we got this other guy? Let's use another color. How we got this other guy here? There's pink here. How we got this guy? Well, this was the result of doing the following, of dividing this into this. So we had 5 times 2t plus 3 raised to a 4 power times 2 times 4t, right? This was divided by this guy. 4 times 2t plus 3 raised to the 4 power. But notice the 4 cancels this 4. This guy cancels this guy. What is left? 5, 2, and t. And this is that, right? So maybe we should say that 5 times 2 times t. This is what justifies the other part. Now better, deep? Better? Yeah. Yeah, it's a special factorization, right? It's not even the regular factorization. Got it, yeah. Because notice that 3 can still be pulled out from here, but for some reason they want this type of factorization, right? So this special type of factorization, I'm giving you the way to get it, guys. Great. Okay, very good, very good. Okay. Moving on to other forms. I found this other form, but this is the same as the one we just did, right? Now, this one are the ones with together with quotient rule, together with quotient rule. Yeah, I'm gonna do it. Okay, I'm gonna show you, and then we will go over the last part, which is applying the chain rule twice. Let me do this, guys. It's very tricky and heavy on computations, and also requires the use of some trigonometric identities. You will see. Number 12. It says h of x here, h of x, h of x. Yeah, let me close and open again. Yeah, h of x equal to this guy, right? And readily, let's just write the outside function in blue here. Outside function, the 4-power function, and in red, the inside function cosine of x over 1 plus sine of x. Okay. Yeah, very good. All right. So if you take the derivative of this function h prime will be derivative of the outside function 4 coming down here. This raised to the third power 1 less, right? And the inside function stays inside here. You leave it alone, right? But then you have to multiply this by the derivative with respect to x of your inside function. And this is where we're going to have to apply the quotient rule, right? Quotient rule, 1 plus sine of x. Yeah, very good. We're going to apply the quotient rule there. All right, this part is pretty much done, right? So let's just write it here. The derivative of h will be here 4 times cosine cube of x over 1 plus sine of x raised to the third power, right? Raised to the third power. Very good. Times this derivative. But how we compute this derivative? Well, let's call this f, let's call this g, and let's apply our quotient rule, right? Remember the derivative, here recall, derivative of f over g is equal to f prime g minus g prime f over g squared, right? This is a quotient rule. So let's use that quotient rule here. So if you use the quotient rule here, the derivative of f, derivative of cosine, is just minus sine, right? Minus sine of x, let's start with that, times the function g as it is, 1 plus sine of x, okay? Minus derivative of g, derivative of this function now, derivative of 1, 0, derivative of sine, cosine, so cosine of x here, multiply by the other function f as it is, cosine of x, right? Cosine of x. So done with the numerator. On the denominator, you keep the g function 1 plus sine of x squared. And remember, do not expand this, right? Leave this alone. All right, so now our derivative becomes the following. This guy, 4 cosine cube of x over 1 plus sine of x cube, right? Times what? Distribute your multiplication over minus sine of x here, sine of x times sine of x minus sine square of x, right? Here minus cosine times cosine square of x, right? Cosine square of x all over 1 plus sine of x squared. Now, anyone could tell me here what is this guy? Let's write it here. 4 cosine cube of x, 1 plus sine of x cubed right here. This guy, factor out, minus sine of x minus sine of x squared plus cosine of x squared. What is this from trigonometry, from precalculus? This guy. I have factored out a negative sign. Look. I see in the chat someone is writing something. Deep. Excellent. Yeah, you made my day. This is just 1, right? This fact comes from precalculus. Sine squared plus cosine squared is 1. All right, great. So we're going to use that. All right. So we have now less stuff here. Cube. This becomes 1 plus sine of x cubed. And notice that this will be minus sine of x minus 1, right? Minus 1. Minus 1. Minus 1 here. All right. So now all divided by this guy. 1 plus sine of x squared. But what is this in the end? Well, this will be 4 cosine cube of x. On the bottom, look, this is raised to a third power, this is raised to a second power. Together, multiplying the two powers with the same base, this will be 1 plus sine of x raised to the 5th power, right? 3 plus 2, 5. Over here, if I factor out the negative 1 sine, I will get sine of x plus 1, right? Sine of x plus 1. Look, I have factored out this negative sign here. But look, this is raised to the 1st power. This is raised to the 5th power. This is going to be, in the end, minus the negative up front, minus 4 cosine cube of x. And on the bottom, look, one of these 1 plus sine of x factors will cancel. 4 of them will stay, right? 4 of them will stay. So 1 plus sine of x raised to the 4th power. And that's it. Yeah, heavy computationally speaking, right? Algebraically speaking, right? We need to use some facts from precalculus, but this should be the final answer, right? All this. So look for this among the choices, and you will see that that is shown on choice D here. This guy, right? 4 cosine cube over 1 plus sine of x raised to the 4th power. Yeah, this is the hardest this could get, right? It's just very tricky and heavy, algebraically speaking. So for you to know. Now, let's try to ensure that we are okay with taking or we're using, better said, right, the chain rule twice, right? What do you mean by that, Professor? Well, I mean this type of thing, right? This type of thing, look, cosine cube of pi times t minus 12, right? There is the cubic function, the cosine function, and this linear function, right? 3 functions there. So let's learn how to deal with that. And I will show you some other cases where you have to use some tricks. Okay, so going back to our notes, let's go back here. You can see here that there is one exercise here at the end. It says applying the chain rule twice. This is the reason, guys, why the chain rule is called chain rule, because it can be applied more than once, sort of 3 times, 4 times, but we will apply it up to 3 times. That will be it at this level, okay? Yeah, so find the derivative, for instance, of this y equals sine cube of 3x squared minus 2. Believe it or not, guys, this function, this composite function, is made of 3 functions. 3 functions, Professor, where are the 3 functions? Will you show us where are the 3 functions? Sure. Look, y equal the following, right? Once you rewrite this as y equal sine of 3x squared minus 2 all raised to the third power, you will see the three functions there. The first function is this, the cubic function, right? Let's call it the outsidemost function. It's cubic function. First function. Second function, there's gonna be this sine function, right? Sine function, second function. But also together with that sine function, there is this other function, 3x squared minus 2, right? So three functions, right? Now, whenever you have a composite function made of three functions, like 1, this quadratic function, 2, this sine function, 3, this cubic function, follow this. Start, let's write it in different color here. Start with the outsidemost function. Start the chain rule with the outsidemost function. Outsidemost function. Okay, and again, that's why they call it the chain rule, right? Because they resemble these nested functions, right? So let's start with the outsidemost function. What would be the outsidemost function? This cubic function, right? Let's start with that. So the chain rule will say, take the derivative of the outsidemost function, this cubic function, right? It will be 3 times something raised to 1 less, raised to a second power, right? This stuff inside remains the same for a moment, right? And then remember the chain rule says that you are supposed to multiply this by the derivative of this guy, right? By the derivative of this guy. But isn't it true, guys, that this guy is itself another composite function? Another composite function on its own right? So it means that we have to apply the chain rule again here, right? So this is why we said this is the application of the chain rule twice. So this will be, look, 3 outside. The exponent 2, remember, we place it in the middle here on the top, 3x squared minus 2 here, close parenthesis, times the derivative of this. The derivative of this again, right? Outside function now sine, inside function 3x squared minus 2. So start with the derivative of your outside function. Derivative of sine is cosine, right? Cosine of what? The inside function, right? 3x squared minus 2. And finally, you are supposed to multiply this by the derivative of your inside function, right? The innermost function, let's call it, or insidemost. Yeah, what is this derivative? Anybody could tell us? It's the derivative of that polynomial function. While I write out the rest here. Cosine of 3x squared minus 2 times this. The derivative of 3x squared minus 2. What is that? Well, derivative of 3x squared is 2 coming down multiplying 3 is just 6x, right? And derivative of minus 2, yes, nothing, 0. Excellent, excellent, Gonka. Very good, right? Yeah, very good. Yeah, so this should be it, right? This should be it after all this work. But now mathematicians love to see everything simplified, right? Clean up. So let's do that, right? 3 multiplied by this guy, that's just 18x, right? 18x. Let's write it like this. And then you can write sine square of 3x squared minus 2. And finally, you can write this cosine of 3x squared minus 2. And this should be it. This should be your final answer, right? Your final answer, the one you have to look through. I'm going to show you. So as you can see, guys, what's the application of the chain rule twice, right? Twice. Yeah, that's why they call it chain rule, right? Because chain rule can be in general applied to nested functions, as you can see here, right? 3 functions nested, right? By a composition, right? Yeah. Yeah, so very good, very good. So let's practice now on this form, application of the chain rule twice, and no more than 2 times, right? At this level, no more than 2 times for the application of the chain rule. So let's look at this problem here. It's somewhere here, I saw it. It's this one. Try to do number 13 and 14. Let's start with 13, okay? Can you try this? Yeah, try this. I will rewrite it here for you. Y equal cosine cube of pi times t minus 12. But let's write it this way, right? So we can identify quickly the outside most function, which is going to be this, the cubic function, right? Outside most. Next, the cosine function, right? And finally, this linear function, pi times t minus 12. Work with this, right? Start by taking the derivative of the outside most function, right? Right as a hint. Start by taking the derivative of the outside most function, which is in this case, this cubic function, right? Yeah, very good, guys. Go ahead. Try that and tell us what is the derivative in case you finish. And remember, derivative of sine cosine, derivative of cosine minus sine, right? Minus sine. Let's check. Goka, I think you're very close. No, I think Goka, you got it now. Yeah, you fixed it. Excellent. Very good work. Yeah, yeah, let's just do it slowly, right? Yeah, I will do this. I will give you a chance to do this other in the bottom, okay? Yeah, very good. Yeah, it's the worst you could get 2 applications of the chain, right? Yeah, very deep, very good, excellent, deep, got it. Yeah, it resembles a chain, right? Because you do it again and again, it resembles the links of a chain. Yeah, a nested function, right? Yeah, so remember when you have 3 functions, the composition of 3 functions, start with the outside most, right? The outside most is this cubic function, right? So start there. So the chain will start there. So the derivative of the outside most function would be 3 coming down as it is, and then the exponent 1 less 2, right? And then you keep this inside function for the moment, cosine of this pi multiplied by t minus 12, right? But then it's not over because you have to multiply this by the derivative with respect to t of this function, cosine of pi times t minus 12, which is itself a composite function, right? So we gotta apply the chain rule again here for this part. But that should be that complicated because we have here already this part done, 3. The number 2 as exponent, place it in the middle, here in the middle. So this will become cosine squared of pi times t minus 12, right? Times derivative of this. Outside function cosine, the derivative of cosine is minus sine of what? Of this guy, pi t minus 12, times the derivative of this guy, right? But the derivative of this guy, notice this is pi times t, pi is a constant. So the derivative of pi times t is just pi. Derivative of minus 12, 0. So this is it, right? This is it. So now just clean up and we will get that y prime should be equal to what? 3 times negative 1 times pi, negative 3 pi, right? Negative 3 pi up front, the number, the constant. Then followed by cosine square of pi t minus 12 times sine here, sine of pi t minus 12. Right? Yeah. Yeah, so this is this guy, right? You see it? Very good. Yeah, as a way to practice important form, right? Try number 14, and then probably I can show you. Yeah, go ahead, Ma.
I have a question. When you said we for derivative cosine pi to minus 12, like the second part, you said we should do the chain rule. Why can't we just do the product rule for that?
Oh, because this is not a product of functions. These are nested functions. Product rule is when you have cosine multiplied by sine or x squared multiplied by sine, multiplication. But notice here, Matt, that this function is inside the cosine function, and this at the same time is inside the cubic function, right? So it's a nested, three functions are nested, right?
Okay.
Composition, yeah, that's why. Yeah, when one function appears inside another function, you have to apply the chain rule. When the two functions appear independently as factors, is there where you apply the product rule, right? Yeah, no product rule here. Yeah, very good. Yeah, good question, good remark. Yeah, clarify your knowledge, guys. This is nested function, right? So we are applying the chain rule twice, that's why. Yeah, try to do number 14, guys, and let's see if we can do one more. So do this one. Again, I'm gonna rewrite this for you this way. I'm gonna put the number for the exponent outside for you to see that this is a nested function, right? Composite function. In reality, the composition of three functions. The three functions are the outsidemost function, this 4 power, outsidemost, right? 4 power. Then we have cosine inside. But inside cosine, this one, this linear function, pi t minus 15, right? Yeah, try to figure out the derivative of this guy. Yeah. Once you get used to this, to identify these nested functions, the components, it shouldn't be hard. Tip, excellent. Yeah, you made my day, Tip. Excellent. Very good. Yeah, tricky, but doable. Yeah, excellent. Yeah, you got it. Yeah, let's do it together so I can show you some other form. Start again by the outsidemost function, which is the 4 power function. So you only start with this derivative, 4 times something raised to 1 less third power. That something is the inside function, this, right? Cosine of pi times t minus 15 here, multiply by the derivative of this guy, right? Derivative of this inside function, derivative with respect to t of cosine of this guy, pi t minus 15. All right, but this is at the same time a composite function, so we gotta apply the chain rule again to get this done, right? So y prime, the final derivative, will be equal to what? 4. Place this number 3 here in the middle, right? Right there. So this is gonna be written as cosine cube of pi times t minus 15 times derivative of this guy. Derivative of cosine is negative sine, right? Negative sine of what? Negative sine of this pi t minus 15 multiplied by the derivative of this inside function, which is just pi, right? Pi, derivative of 15, 0, so pi. So this is it. Now, just put things together, right? So this will be equal to what? 4 times negative 1 times pi minus 4 pi up front, followed by cosine cube of pi times t minus 15, multiply by this sine of pi t minus 15, right? Minus 15. And this should be it. This should be the final answer. And if you look through the choices, you will see that for 14, very good is B, right? This. Great. Okay, guys, now let me show you some other tricky ones, the ones that require some trigonometric manipulation. But let's see if at least I can find one here. Yeah, it's not really trigonometric manipulation. It's just that you have to get the knowledge of some derivative of trigonometric function, right? But again, if derivative of sine, cosine, derivative of cosine minus sine, derivative of tan secant square, all those results are here, right? Here in our website, you will find these sheets with formulas for the derivatives in case you haven't memorized them. All right, so for example, let's do this. R equal secant of theta plus tangent of theta all raised to minus 3. All right, let's say I want to find the derivative. I quickly identify that this is my outside function, right? The negative third power, right? Let's call it negative third power. And my inside function is the secant of theta plus tangent of theta, right? This is my inside function. So the chain rule says, okay, in order to take the derivative of this composite function, I start with the derivative of the outside function, which is going to be negative 3 coming down as it is, multiplied by what? Something raised to negative 3 minus 1, but negative 3 minus 1 is negative 4, right? Negative 4. This part stays inside, leave the inside function alone. And then multiply this by the derivative with respect to theta of the inside function to complete this, right? R prime will be negative 3. This, I can write it on the bottom, right? So negative 3 on the top, this guy, secant of theta plus tangent of theta, all raised to 4 power in the bottom, because it's a negative exponent. I don't want it up there. Write it down here. Times this derivative. But what is the derivative of secant? The derivative of secant is secant of theta times tangent of theta, right? And the derivative of tangent is secant square of theta, right? Now notice I can factor out secant, right? I can factor out secant, and this will lead to the following. Let me erase this product rule. Yeah, this will lead to the following. R prime equal minus 3 over secant of theta plus tangent of theta all raised to 4 power, right? It's on the bottom. On the top, I factor out secant of theta, and inside I get secant of theta into this, secant of theta cancels, this is tangent of theta, plus secant of theta into secant squared, secant of theta, right? Secant of theta. Notice that this is tangent of theta plus secant of theta, this is tangent of theta plus secant of theta raised to 4 power. Simplifying these two, you will get the following: minus 3 on the top, and on the bottom, this secant of theta plus tangent of theta raised to 1 less, right? 1 less, because 1 was canceled, 1 factor, so raised to a third power. And looking through the choices, for this number 8, you should find that this is just equal to Don't forget the secant there, right? The secant that is there, this guy. So looking through the choices is this guy, right? See. You follow, guys? Yeah. So this is what I mean when you have to do some factorization, some algebraic manipulation, some simplifications, right? It's better said. This is this. All right. So let's see if we can do something, one more form, but to finish with this. Yeah, we did this. This form is taken care of. This is similar to the one that we just did. Can we finish with this? Take the derivative of this function, 1 plus sine of 11t raised to -4. Hint, this is your outside function. And this is your inside function, right? The one inside. So take the derivative of this using the chain rule. Notice that this is also a composite function inside, but it shouldn't be a problem, right? Yeah, try guys. Oh, I see we're running out of time, so probably we should do this together. Maybe I should write this in green so you can see that this is another function there. All right, let's start the derivative. The derivative of the outside function will be -4 times -4 minus 1, -4 minus 1 minus 5. You keep this inside, right? 1 plus sine of this guy. But notice now that you have to multiply by the derivative of this guy, right? Which shouldn't be difficult to find. 1 plus sine of 11t here. But what is that? We're going to compute this. Well, this is going to be y prime equal -4 on the top. I'm going to write this power down here as 1 plus sine of 11t all raised to the 5th power, right? Times this derivative. The derivative can be distributed over sums. Derivative of the constant function 1, 0. Derivative of this sine of 11t is derivative of outside function sine is cosine of 11t, but then you must multiply by the derivative of the inside function. Derivative of 11t is 11, and this should be it, right? So finally, derivative here will be equal to -4 times 11 minus 44 multiplied by cosine of 11t, all divided by this guy, 1 plus. Well, notice that they have not written this on the bottom, so just put it back in there, right? Often 99% of the time they do it, but this time they just left this alone. So this should be 1 plus sine of 11t raised to -5, right? And that should be there. So for 15, if you look through the choices, you will see that this is just this guy, right? -44. The cosine, they put it at the end. This one, they put it here. Order of the factors does not change the product, so that's it. Okay, guys, I think we have enough. Next